9, determine the convergence or divergence of this series, the sum from n from 3 to infinity, of sine of e to the n plus square root n divided by n squared plus n. So as soon as I look at this, I know I'm going to try to see if this series is absolutely convergent. Why is that? This is the dead giveaway here, sine of e to the n plus square root n. We know that sine of anything is always less than or equal to 1 in absolute value. And so this nasty thing in there, that's just a red herring. You could make that as nasty as you wanted, and this property is still going to be true. So because I know the absolute value of sine of anything is less than or equal to 1, what I then know is so sine of e to the n plus square root n divided by n squared plus 1 n. I take the absolute value of that. That is less than or equal to the absolute value of this is less than or equal to 1 divided by n squared plus n. So my hope, and it turns out to be a correct hope, is that this series, I want to show that this series is convergent, because if I can show that this series is convergent, and I'm using the direct comparison test and absolute convergence to conclude that this original series is convergent. So let's put all these pieces together. So first, I observe that 1 over n squared plus n is less than or equal to 1 over n squared. And I know that this series converges. It's a p-series with p is equal to 2. So because this series converges, now this series converges by the direct comparison test with this series right here. I guess to be good citizens, we should also observe here that this is non-negative. I mean, that's the whole reason that we took absolute values in the first place, is to get non-negativity here. Okay, so because this series converges, now we know that this series, the sum from n from, note that I was messing around here with 3, 1, 1. The exact starting place of my series doesn't really matter. Another red herring in the problem. Sine of e to the n plus square root n divided by n squared plus n. I know that this converges by direct comparison test with this series right here. And so when I slap on the absolute value bars, that means, and this series converges, that means that this one, my original series, absolutely converges. So just to recap all of this here, because this series converges because it's a p-series, this series converges by direct comparison test with this, and so this series converges by direct comparison test with this. And so therefore this series absolutely converges. But all the direct comparison tests that came later, that's the key step in the problem, is whenever you see a sine or a cosine, you very much should be thinking absolute convergence, because sines and cosines are sometimes positive, sines sometimes negative, and so we can show that yes, it is absolutely convergent.